In section 11.1, we will introduce a new type of distribution, and that distribution is called the chi-square distribution. So first of all, some facts about the chi-square distribution. The notation for the chi-square distribution is listed here. You can see that's actually the Greek letter chi, and you can see it's chi squared. And then it is a distribution, and it has a certain number of degrees of freedom. And the degrees of freedom depends on the way that the chi-square distribution is being used. So we will need to know, just like in the t distribution, we would have to know the degrees of freedom. We'll have to know that degrees of freedom also in the chi-square distribution. Fact number 1, chi-squared is a continuous random variable. Remember, we have discrete and continuous random variables. This is continuous, just like all the ones that we've been dealing with recently. Fact number 2, the shape of the chi-square distribution depends on the degrees of freedom, just like it did for the t distribution, which is called the student's t distribution. Fact number 3, the values of the chi-square distribution are non-negative, so they're never negative, so that's different than the t and the z distributions, but they are never negative. They're always greater than or equal to 0. Fact number 4, the mean of the chi-square distribution is the degrees of freedom. So in other words, mu equals that value that is the degrees of freedom. Fact number 5, sigma is equal to sigma is equal to the square root of 2 times the degrees of freedom. Fact number 6, the chi-square distribution is always skewed right, and we're going to see that when we look at some pictures of that distribution. Fact number 7, the mean, which remember that is the degrees of freedom, is just to the right of the peak of the density curve. So we're going to see our curve. It's not a bell curve because it's skewed to the right, but where that highest peak is, just to the right of that will be our degrees of freedom. Fact number 8, as the number of degrees of freedom increases, the chi-square distribution becomes more nearly symmetric. And basically, when the degrees of freedom is more than 90, it's fairly symmetric. Now, again, the same thing happened with the t distribution, where it looked more like a normal distribution. It is going to be symmetric, but it's still going to be all positive values, which still differs from the t and the z distributions that we've talked about previously. So here are some pictures of various chi-square distributions with various numbers of degrees of freedom. So if you think about this, remember they said the degrees of freedom is just to the right of the peak. So like a degree of freedom of 1 would probably be that first one there. Okay? Degree of freedom of 2 would probably be this one right here. Degrees of freedom of 3 would probably be like that one right, maybe this one right here. So you can see as that mean or the degrees of freedom moves further to the left, your distribution is going to become more symmetric and less obviously skewed right. And that is the end of section 11.1, just some introductory information about the chi-square distribution. You've got those 3 graded problems. And again, if you have questions on any of those, please let me know and I will try and answer them.